Okay, here we go. We're doing work problems, which I think we're hitting word problems again, but the word problems are much easier this time around because you've experienced them all. They're the same kind of word problems. Yes. Okay. So let's look at, I don't actually use this box to begin with when I have simple work problems. So I'm going to kind of go, let's go beyond this, and we'll come back to this afterwards. All right, so when there are not multiple unknowns, and this is just, I'm working, you're working, when we work together, how fast can we do it? It's pretty simple. You can write it as job over time plus job over time equals job over time. Okay? I'm going to explain. So let's say my job that I complete over in how long versus McKenna's jobs, how many jobs can she complete in how much time, and then the last one is the together time. So in this case we're talking about Jeff and Hal, and they're painting a room. So Jeff's, let's say the first one is Jeff, this is Hal, and this is together. Okay? So I'm going to do one, we say that it takes Jeff, he can complete one job in 4 hours, and Hal can complete one job in how long?
5.
And together they can complete one job in how many hours? X hours. Pretty easy, right? That's very straightforward. So if they're just talking about mixing work rates, I generally do it like this. And then what would be my least common denominator? Yes? 20x. I'm going to multiply both sides by 20x. And now I'm going to distribute, and I get a 5x. And I'm going to distribute here, and I get plus 4x. And I distribute here, and we get equals 20. 9x equals 20. Divide by 9, divide by 9. X equals, 9 goes into 22 times, and I have a remainder of 2/9 hours. Now, if I want to convert that to minutes, what would I multiply 2/9 by? 60. I could leave it 2 hours and how many minutes? Or you can just do this, 2 and 2/9 hours. Okay, questions there? All right. Can I move on? Now, let's move on to the next one. They look at how they break it down when they do it. They do one job in 4 hours and the middle part they make is together time. Right? His work rate times the together time. His work rate times together time. Multiply across, add going up and down. That's how they do it. It's so easy my way. If there's not a lot of unknowns, I don't use this. Okay? For something like that, where there's not a mix in times, but you'll see it'll get more complicated. So, let's go on to the next one. I want you to practice this. Do the next one. It's the same thing, only this one is talking about a water hose. You take the water hose and you're filling a pool. So one hose can fill a pool in 10 hours, and a different hose takes only 6 hours. How long would it take if both hoses are used? Okay? So try that next one. Pause the recording and try doing job over time plus job over time plus job over time. So I'm going to go right to the answer because we're not really using this. Though it would be 1 in 10, 1 in 6, x and x. And then we're adding 1/10 x plus 1/6 x equals 1 complete job. And did you get 3 3/4 hours? Yes. David? No. In this case, you're not. The question is, should we leave this as an improper fraction? This is a story problem. I want you to make sense of the story. We don't talk about hours in terms of. I work 30, it'll take us 30 over 8 hours. Nobody knows what that means. Turn it into something we understand. It'll take 3 3/4 hours. Now, if you want to convert to the minutes, that's fine. 3 hours and 45 minutes, but I don't care. You can leave it as the fraction. Okay, questions? Kendall, are these easier word problems? Yeah? Okay. Because he was like, He gave me the big no. Okay, here's where it gets complicated. Of course, now I'm going to use the box. Okay? Work rate. So let's make our box. And I'm going to use my own words and describe it. This is the same thing. This is going to be really your job over time. Right? This is together time. And this is just multiply across, right? It tells us what to do. Okay, you ready?
Yeah.
Okay, what is John's work rate going to be? Raising a quiet hand. Daniel.
80 minutes.
No, what is his work rate going to be? Job over time. What am I putting? What?
1 over 80.
1 over 80. Kendall, what will Sam's work rate be? 1 over what?
2 hours.
2 hours. Now, because the other one is in minutes, we either have to convert both to hours or both to minutes. How many minutes is 2 hours? Okay, 120. So I'm going to do 1 over 120. I think that's easier than converting 80 to a decimal, right? We know 1 hour is 60 minutes, the other hour is another 60 minutes, that makes 120. All right, now, do we know their together time? Okay. Well, we both know, don't they both work a certain amount of time together? That's unknown. So we'll call that X. We call that X, their together time. But how is John's different? He works plus 30. Now, we're doing the same thing we did before. We multiply going across, and we add going up and down, and it equals one complete job. So this would be 1 over 80 times X plus 30. The next one is 1 over 120. That's just going to be an X, times X equals one complete job. Are you guys with me?
Yeah.
Okay, and that's your equation, really. Going up and down. Now, do you remember how to clear before we distribute? What do I have to do to clear before I distribute? Huh? What would be the least common denominator here? 240. I always take the bigger number. Does 80 go into 120? So take the bigger number and go 120 times 1, 120 times 2, 240. Oh, 80 does go into that. Okay? So I'm going to multiply everything by 240. I just want to show you as I'm doing it. I don't know why I jumped there. Okay, now, when I distribute, really, this is all one term, guys, because it's connected by multiplication. So 80 goes into that how many times? 3 times. We're going to get 3 times X plus 30. And when I distribute here, 120 goes into this plus 2X. And when I distribute the 240 here, what does it become? 240. So I'm going to distribute. I get 3X. 3X plus 30 plus 2X equals 240. Plus 90. Oh, plus 90, you're right. I didn't distribute there. Plus 90. And now we are going to, it's 5x plus 90 equals 240. Subtract 90, 5x equals 150, divide by 5, x equals 30. Now go back to the story. 30 what? How long will it take if John works alone, 30 minutes, then Sam helps him finish? How much longer will the job take? 30 more minutes. Okay. Yes, David. Because it's one complete job. It's John's work time is this. John's work rate plus Sam's work rate equals one complete job. Okay? Are you guys okay with that?
Yeah.
Okay? Okay. Daniel.
So when it says if John works all 30 minutes and Sam helps him finish, how much longer will the job take?
This right here is their how much longer.
Okay.
Right? Because it's their together time that we're naming. He said the together time that they're doing is X. We don't know how much it is. I know we did plus 30, but John works an additional 30. Okay? Yes.
Do I understand a little bit? But, so you're doing job over time, right? So why does the job always equal 1?
Well, unless you're doing 2 jobs, painting 2 rooms.
Okay.
They would have to say that. Right? Okay. Now, same thing. Let's see if this gets any easier. Work rate times time equals work done. Job over time times together time equals work done. Okay? And we're comparing Marty and Julie. Okay. Jan, what is Julie's work rate?
1 over 8.
Good. 1 over 8. What is Marty's work rate? Let's go, Vardon. 1 over 10. Now, let's look at the time. If Julie and Marty work together for 4 hours, how much longer will it take Julie to finish the job alone? What is the time going to look like? Let's go with Matthew.
Could it be x minus 4 for...
How about let's talk about let's list what they both do. They both do 4. Instead of minus, let's just talk about what they both did. Now, how would I show Matthew, Julie working more? Okay, Daniel?
Well,
It says if Julie and Marty work together for 4 hours, how long will it take Julie to finish the job alone?
it will take her plus 4.
No, they both did 4 hours together. Zach, plus X, plus an unknown amount of time alone.
But
It says Julie and Marty work together for 4 hours. So we have to put the 4 there.
okay,
How long will it take Julie to finish it alone?
after the 4 hours pass.
Right.
Okay.
So now we just multiply across. 1/8 times 4 plus X. 1/10 times 4, right, over 1. And what am I putting down here, David? 1 complete job. You guys with me? Let's hope that that's what it says. Yep. Okay. Now, you could have simplified that first. Okay. What can we do to clear our denominator? How about Charlie Wilson?
So you multiply it by the LCM?
Which would be, take the bigger number. 10, they don't both go into it. 20,
20, no.
30,
No.
40.
Yeah.
Okay, multiplying by 40. Okay? And then we'll get 5 times the quantity of 4 plus x, and 4 times 4, and equals 40. Right? Yes. Because this is one term. So I don't want to do it into the term twice. We multiply all terms. That's the next term because it's separated by a plus. That's the third term. So I'm going to cross cancel here, and it becomes 5. Now I can distribute in. 20 plus 5x plus 16 equals 40. Did I answer your question?
Yeah.
And then I get 20 and 16 is 36 equals 40, 5x. Okay, subtract the 36, subtract 36. I get 4 equals 5x, divide by 5, divide by 5. X equals 4/5 of an hour. Or we can do 4/5 times 60. It would be 48 minutes. Got it? Yes.
At the beginning of the equation, why would you leave it as 4/10 and not 2/5?
You could have done 2/5. We're not going to leave it there eventually, right? I just multiplied it out, so I didn't have to do much. We do eventually get it. Now, somebody said to me last time, well, what happens if I multiply by 80? Well, you could have multiplied by 80, and you would have gotten the same number. It just means in the end you're going to be reducing more. Got it? Okay, we have 2 distance problems. Rate times time equals distance, right? Okay, now, I've got 2 planes, one going west and one going east. So, don't worry about it. It's the same stuff. It's going to be easier this time. Let's fill in what we know. 2 planes leave Chicago at the same time. The westbound plane travels 900 miles. Where does 900 go? 900 miles.
Oh, distance.
Okay, that is for the west, right? The eastbound goes 150 faster than and travels 1,200 miles. So this is 1,200. Now let's talk about. We leave at the same time. They're saying how long does it take them to go? 900 and 1,200. This is what my hands. They start at the same distance. 900 and 1,200. Tell me about the time. Leaving it. Yeah, it's the same. Do I know what it is? So we call it T. Okay? Next one, the rate. Now, east goes 150 faster. So, Oscar, how am I going to show the east?
It would be the west plus 150.
No, it says east goes 150 faster. Well, let's call it what it is. Instead of X, let's use R. Okay? R plus 150 for the east. We don't know what the rate of either plane is, so we call the rate R. And all we know is that east is 150 faster. You guys with me?
Yes.
Now, remember how we do rate times time equals distance? Well, since time is all on its own, can't I just divide by R, divide by R? Isn't time also equal to distance over rate? So if time equals on the west, right, the time is equal to 900 over T. You with me? And the other one is equal, T equals what? 1,200 over R plus 150. And if they're equivalent, can't we do substitution? Right? So we get 900 over T equals 1,200 over R plus 150. And now, how do we solve it? Did I make a mistake?
Yeah.
What?
Denominator that has a T in it should be an R. 900 over R.
Oh, You're right. Over R. Everybody's hands were going up. Sorry. That should be an R. That should be an R. There we go. Okay. So now we're doing cross products. Our proportions. So I get 1200 R, and then I get 900 times R plus 150 equals, got it? Questions? So we're getting, now we have to multiply it out. I'm going to, it's okay. I'll bring it back in. Isn't that the same? And neater. Okay, we're going to distribute. We get 900R plus 135,000 equals 1,200R. Subtract the 900R, divide out 300 on both sides, and we get 450 is equal to R. So the west travels how fast? West travels, yep.
450 miles per hour.
And the east?
Wait.
28?
Wait, no.
What did you? 600.
Wait.
Okay?
What was supposed to be?
Yes.
Can we use a calculator for that, bro? Like that tape?
Yeah, that's fine. Tonight? Yeah. Shh. Okay, questions. All right, last problem. Practicing. And they love to give you these on a high school entrance exam or an SAT. Anne leaves for school and walks home for 3.75 miles. Rate times time equals distance. You want to try and fill your box? Why don't you try it? And let's pause it and see if you can fill your... All right. First, let's fill what we know. Instead of doing anything with variable, I don't want to fill anything with variables.
The distance for Anne is 3.75 miles.
Uh-huh.
And the distance for Mark is 6 miles.
Good. And then, what do we know?
Okay. So we know that Mark's rate is 1.5 miles faster than Anne.
So what would he be?
So he'd be R plus 1.5.
R plus 1.5, and she'll just be R.
And then the time is unknown for both of them, so it'd be T.
And remember, rate times time equals distance, so divide by R, divide by R. T is equal to distance over rate. So, the first one will be T equals what, Cubby?
T equals 3.75 plus 6.
No.
RT.
Look at right here. Did you not make sense of this?
Over R.
Good. And what is the next one? T equals?
6 over R plus 1.5.
Okay. And then, what do I do, Cubby?
Then you multiply.
No. Okay, it's a system of equations. Ben. Okay, before that, how can I do a proportion if I don't have a proportion? Yes.
Make a proportion.
With?
3.75 over R.
What's this called when I do this?
Oh, you substitute.
Substitution method. We use substitution. And now we get 3.75 over R equals 6 over R plus 1.5. And now we're doing our cross product. 6R equals 3.75. I'm going to go to the... Right? I think at this point, well... I guess you're using a calculator. You may as well just keep the decimal. At this point, I probably would clear it. Yes. And then you divide, and we end up with 2.5 R. What does that mean, 2.5? 2.5 what? Anne is walking 2.5 miles per hour. and Mark runs 4 miles per hour. Does that make sense? Okay, questions? Okay, are these, yes.
But it's asking you for the time.
Oh, so then you have the ability to find your time. So now we have to go back, and we're going to be, how long did it take them? Their time is the same. Once I find the R, I really don't even have to find Mark's rate. I can just substitute it into either original problem. Does that make sense?
So in the original equation, you just substitute in 2.5.
Either original. You can substitute 2.5 into this one or this one. Right? And then you'll get, probably that one looks a little easier because that becomes 6 over 4 and that becomes 1.5. Okay? That's easier to do. All right. That's the end of the lesson. Oh, let's see, one more. The reciprocal of 4 less than x is 3 times the reciprocal. The reciprocal of 4 less than x. What? 1 over 4 minus x. Good. Less than x. Wait, close. It has a than there. Huh? Yes. Oh, isn't that sneaky? It had a than there. Is equals. Is my equals. Okay? 3 times the reciprocal of x. I think it's 3 times the reciprocal of x.
3 times 1 over x.
Is that what you said? Okay. Okay, so it would really be 3 over x. Right? Because 3 times 1 over x. And then we can say, what are our restrictions? Our x can't equal 4. And then we do our cross products. Oh, x can equal 4 in the first denominator. In the second denominator, x can equal 0. And we get x equals 6. Okay, questions? All right, that's the recording. Okay, any questions?